K Love Bites, a fast-growing artisan bakery renowned for its signature cakes and premium pastries, was founded by an intelligent and accomplished lady, Ivwanji Nambela Kazier, proud graduate of Copperbelt University with a bachelor's degree in accountancy. She is also a qualified chartered accountant through. Okay, this information not necessary for all the solutions. Yes. The company is now considering a major investment to upgrade its production line in order to improve the product quality, enhance operational efficiency, and position itself for expansion into regional markets. The proposed upgrade involves the purchase of a new state-of-the-art baking system at the cost of $465,000. So we record this is the cost of the investment. The new equipment would replace existing ovens and mixers that currently have a market value of $69,000. The old equipment was originally purchased for $540,000 and is now 3/4 depreciated. If retained for another 12 years, the old equipment salvage value is projected to be $15,000. The new equipment is expected to have a useful life of 12 years with an estimated salvage value of $90,000. So here, this information, depreciation, we just need to get the salvage value here. Kazila Love Bites projects that as a result of the upgrade, the annual operating income before tax will increase by $60,000 for the first 3 years due to initial demand growth and enhanced product quality, and by $75,000 per year for the subsequent 9 years. As brand loyalty deepens and the bakery gains larger retail distribution contracts, However, implementing this investment will require an immediate increase in working capital over $40,000 at the time of the purchase to support additional ingredient inventory, packaging materials, and increased receivables from wholesale customers. This additional working capital is expected to be fully recovered at the end of the equipment's useful life. This working capital, we're going to add it first to the cost of the investment, and also at the end of the investment it's coming back to be fully recovered. The company operates with a corporate tax rate of 40% and has an after-tax cost of capital of 15%. Depreciation for both the old and the new equipment is calculated on a straight line basis. CEO Ivwananji has asked you as a financial analyst to determine whether the bakery should proceed with this investment. Use the information provided, calculate the net present value and the internal rate of return for the project period, and state with supporting reasons whether it is financially viable. That was an essay. That was an essay. By the time you're done reading that question, 30 minutes have passed. Okay, so we're using the net present value. The net present value, remember colleagues, this is where we're going to, the money that we're going to expect in the future, we're going to convert it into today's value. Okay, The net present value technique is using this formula. Present value equals future value 1 plus r to the power negative t okay. So here we're going to have our years. Here we're going to have our cash flows. Here we're going to have our discount factor. Here we're going to have our present value. Okay. So in this question here, they've told us this equipment is going to cost 465,000. Okay, and they said we need working capital of 40,000. So we are going to add this 465,000 plus the 40,000. Okay, basically to invest in this project. So here we're going to say 465,000 plus 40,000. What do we get? Oh, just excuse me for 1 minute. I just add that when I get back. Let me know what we get. Yes, 465,000 plus 40,000. What do we get? Mr. James, Madam, oh, Mr. Austin. $505,000. That is year one. Then we see the cash flows. So they said 60,000 for the first 3 years. So you say year one. This is an, instead of doing year one, year two, year three, since it's 12 years in this question, so you will, to save time in the exam, just use annuities. So year one to year three, 60,000. This is an annuity. Okay. If you want to put year one 60,000, year two 60,000, year three 60,000, that is up to you. Okay. Then what else? They told us 60,000 for the first 3 years. And then 75,000 for the next 9 years. So from year 4 to year 12, $90,000. Then again in year 12, remember, this has got a salvage value. This equipment, what did they say the salvage value is? Salvage value of 90,000. So meaning at the end of year 12, you can sell this equipment for 90,000. Okay, so salvage value of 90,000 plus, remember the working capital will be regained. So 90 plus 40, 130,000. Any questions? Depreciation is not used in this net present value technique. Okay, so those depreciation figures there, you're not going to use it unless we are dealing with the accounting rate of return. That's where you find the depreciation. But net present value and internal rate of return, there is no need for depreciation. Hello? Good evening. Yes. Any questions so far? Okay. So in year 0, this 505,000 represented as a negative value because it represents money going out. We're investing it. Then these are positive values because it's money coming in. Okay. So let me use the annuity and present value tables to get this. They told us our cost of capital was what? Cost of capital 15%. 15%. So we go to our present value table. If you don't have this table on the day of the exam, you can just use this 1 plus r. You just do 1 plus 0.15, then you use it for year 0 and year 12 only. Okay, so you put this, when you put 1.15 to the power negative 0, your discount factor will be 1. Okay, if you put 1.15 to the power negative 12 on our table, discount factor here 15%, years 12 years here. Okay, the number of years, you see them on the side here, so here or either side here, 12 years. Okay, so 0.187, that's for year 12. This is for the working capital and the salvage value. Then for years 1 to 3 and years 4 to 12, we go to the annuity table. Okay, so you say 15% here, the annuity table. 3 years, for year 1 to 3, you go to 3 years. Okay, so 3 years, 2.283. Okay, 2.283. Okay, then so you look at 3 years, don't go on 1 year, no, go on year 3 in the annuity table, and then again on the annuity table year 12 again, year 12, 5.421. Okay, any questions, colleagues? For the annuities, if you're not using the table, you use this formula here, the present value for annuity formula. Okay, R is 15, 0.15, so you calculate manually if you're not using the tables. Yes. So are there any questions before we get the net present value? So we get the present values. You're going to say negative 505,000 minus 1, negative 500,000. 60,000 times 2.283, and you get 136,980. 90,000 multiplied by 5.21, you get 487,890. And 130,000 multiplied by 0.187, you get 24,310. Okay, then we add up to see if we have a positive or a negative net present value. Yes, we have a positive net present value of 144,180. So this woman should accept the project because the net present value is positive. Any questions? Where is this? Any questions, colleagues? Okay, so next is the internal rate of return. Okay, these cash flows, you just want to say, you want to find out what return is it in terms of percent format. What return are we getting from this project? Okay, so since our first net present value is positive, so the discount factor, we need to increase it. Why are we increasing the discount factor? So that we can get a negative net present value. Okay. That's why we are increasing it. Okay, so let's increase it to 90%, because in the exam, as I said, you have to, if you get another positive net present value, you have to change, you have to increase again. So I always advise be extravagant. Okay, so now using a discount factor of 90%. Okay, so discount factor in year 0 is always 1. Let's calculate our annuity factor with 90%. 1 minus 1 plus 0.9 the power negative 3, that's for the 3 years first, over 0.9. Okay, our annuity factor for 9 years, for 3 years. So 1 plus 0.9 is 1.9. So you're going to say 1 minus 1.9 to the power negative 3 0.854 divided by 0.9, you get 0.94 as our discount factor. Okay, for here, here's 1, 2, 3, discount factor 0.94. Then we get the same annuity factor for 12 years. 1.9 to the power negative 12 over 0.9. Get 1.11. You just confirm if that's up. Yes, 1.9 to the power negative 12. Okay, so we'll get 1.11. So here we put 1.11 because 90% you can't find it on the annuity tables. Okay. Then for the final year 12, which is just a one-off, just going to do 1. We'll use the present value formula. 1.9 to the power, R is 0.9. 1.9 to the power negative 12 0.000. This is a 0.00045. 0.000. Yes. So we get now our new discount factors. Negative 505 multiplied by 1, negative 505. 60,000 multiplied by 0.94, 56,400. 90,000 multiplied by 1.11, 99,900. 130,000 multiplied by 0.0045, 58.5. Then we add we get a negative net present value of negative 384,642. Any questions? And then we total up. Oh, we already totaled up, huh? Okay, then now we can calculate the internal rate of return. Hey, what have I done there? put in the answers. Okay, yes. So our internal rate of return formula lower discount rate plus the net present value with the lower discount rate, open brackets, net present value, lower discount rate minus net present value, higher discount rate, open brackets, H minus higher discount rate minus the lower discount rate. Lower discount rate 15%. Net present value with the lower discount rate 144,180. Over 144,180 minus negative 348,642 open brackets, the higher discount rate 90% minus the lower discount rate 15%. So we do our tabulations. We start with the denominator. 144,180 minus negative 348,642. Get, when we do this in the denominator, we get we get 492,000 divided by, we get 492,822 90 minus 15, that is 25%. So 144,180 divided by 492,822, 0.292, multiplied by 25%, 7.31 plus 15%, you get 22.31%. Okay, I divided, multiplied, then added. Okay, so since our internal rate of return is greater than the cost of capital, meaning the return we're generating from our project is greater than the cost of the project, because the cost of capital or the cost of financing for the project was 15%, we accept the project. Okay, we accept, just as the NPV said, also with the IRR, we accept the project.